Managing multiple physical disks attached directly to a computer can often be a tedious task for administrators. To overcome this problem, many organizations use SANs that group physical disks together. SANs require specialized configuration and sometimes specialized hardware, which makes them expensive. To overcome these issues, you can use the storage spaces feature. It pools disks together and presents them to the operating system as a single disk. This module explains how to configure and implement the storage spaces feature. Objectives. After completing this module, you will be able to explain what the storage spaces feature is, describe the features of storage spaces, discuss in which scenarios to use storage spaces, show how to configure storage spaces, explore storage spaces. Storage Spaces is a storage virtualization technology in Windows and Windows Server that can help protect your data from drive failures. It is conceptually similar to RAID, but implemented in software. You can use storage spaces to group 3 or more drives together into a storage pool, and then use capacity from that pool to create storage spaces. These typically store extra copies of your data, so if one of your drives fails, you still have an intact copy of your data. If you run low on capacity, just add more drives to the storage pool. Storage Spaces is available for NTFS and ReFS volumes, providing redundancy and pooled storage for numerous internal and external drives of differing sizes and interfaces. You can use storage spaces to add physical disks of any type and size to a storage pool, and then create highly available virtual disks from the storage pool. The primary advantage of storage spaces is that you do not have to manage single disks, but can manage multiple disks as one unit. To create a highly available virtual disk, you need the following. Physical disk. Physical disks are disks such as serial ATA, SATA, or serially attached SCSI, SAS disks. If you want to add physical disks to a storage pool, the disks need to satisfy the following requirements. Creating a storage pool requires one physical disk. Creating a resilient mirror. Virtual disk requires a minimum of 2 physical disks. Creating a virtual disk with resiliency through parity requires a minimum of 3 physical disks. Three-way mirroring requires at least 5 physical disks. Disks must be blank and unformatted. No volume must exist on them. Disks attachment can use a variety of bus interfaces including SAS, SATA, Small Computer System Interface, SCSI, and USB. Storage pool. A storage pool is a collection of one or more physical disks that you can use to create virtual disks. You can add all non-formatted physical disks and disks that do not have an attachment to another storage pool to a storage pool. Storage space. This is similar to a physical disk from the perspective of users and programs. However, storage spaces are more flexible because they include thin provisioning or just-in-time JIT allocations, and they include resiliency to physical disk failures with built-in functionality such as mirroring. Disk drive. You can access this volume from your Windows operating system, for example, by using a drive letter. Note: Storage Spaces Direct is for creating highly scalable storage solutions. Unlike Storage Spaces, which is intended to create storage pools for the local client, Storage Spaces Direct is designed to configure local drives on a server, performing a role similar to traditional SAN or NAS arrays at a lower cost. This feature is not designed for client and is only available on Windows Server, only available in Windows Server Data Center Edition. Examine features of storage spaces. You can create storage spaces from storage pools. If your storage pool contains more than one disk, you can also create redundant storage spaces. To configure storage spaces in the control panel or Windows PowerShell, you need to consider the following features and their redundancy functionalities. Storage layout. Configure this feature to define the number of disks from the storage pool that you allocate to a virtual disk. Valid options include simple. A simple space has data striping but no redundancy. In data striping, logically sequential data is segmented across all disks in such a way that provides access for these sequential segments to different physical storage drives. Striping makes it possible to access multiple segments of data concurrently. Do not host important data on a simple volume because it provides no failover capabilities when the disk that is storing the data fails. This is similar to the striped volumes discussed earlier. Two-way and three-way mirrors. Mirror spaces maintain 2 or 3 copies of the data that they host, 2 data copies for two-way mirrors, and 3 data copies for three-way mirrors. Data duplication happens with every write to ensure that all data copies are always current. Mirror spaces also stripe the data across multiple physical drives. Mirror spaces provide the benefit of greater data throughput and lower access latency. They also do not introduce a risk of corrupting at-rest data and do not require the extra journaling stage when writing data. Two-way mirrors are similar to the mirrored volumes discussed earlier. Parity. A parity space is similar to RAID 5. Storage spaces stores data, along with parity information, striped across multiple physical drives. Parity enables storage spaces to continue servicing read and write requests, even when a drive has failed. Parity always rotates across available disks to enable I/O optimization. Storage spaces require a minimum of 3 physical drives for parity spaces. Parity spaces have increased resiliency through journaling. There is no equivalent to parity in volumes on dynamic disks. Provisioning schemes. You can provision a virtual disk by using 2 different schemes. Thin provisioning space. Thin provisioning is a mechanism that enables you to allocate storage when the storage space needs it. The storage pool organizes the storage capacity into provisioning slabs. The allocation does not happen until the point when datasets grow to require the storage. As opposed to the traditional fixed storage allocation method, in which you might allocate large pools of storage capacity that remain unused, thin provisioning optimizes utilization of available storage. Organizations also can save on operating costs, such as electricity and floor space, associated with keeping the unused drives operating. The disadvantage of using thin provisioning is lower disk performance because storage allocation occurs when the pool needs extra storage. Fixed or thick provisioning space. With storage spaces, fixed provision spaces also employ the flexible provisioning slabs. The difference between thin provisioning and a fixed provisioning space is that the storage capacity allocation in the fixed provisioning space happens at the same time as storage space creation. Examine scenarios for storage spaces. Storage spaces can simplify your storage administration and allow for easy storage growth. In most enterprises, servers will be the only computers using storage spaces. Small offices might use storage spaces in Windows to create high capacity and storage that is easy to administer. Thin provisioning storage. The need for storage is always growing. Smaller companies without IT staff might find it difficult to add new storage to their solutions today. Storage spaces can help with storage growth when you use thin provisioning. Thin provisioning will allow you to create a bigger storage space than what the disks will be able to store. You then add the disks to the storage space when you need more storage, and the storage space will automatically claim the space on the disks. Reliable storage. Small businesses often do not have the funds for acquiring enterprise-grade storage solutions. Storage spaces can help these companies get fault-tolerant storage for an affordable price. Storage spaces has 2 resiliency types that provide fault tolerance. These will help to make the storage highly available in case of disk failures. Two-way mirror and parity can function even when one drive fails. Three-way mirror can function with 2 drive failures. High-performance storage. Users who have computing needs with high-performance storage, such as video editing, might also benefit from storage spaces. When you create a storage space with parity resilience, the striping will give a better performance reading and writing to the storage. When you use SSDs as the physical drives, you should be able to get the required disk I/O